بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. Mohamed Sa with you, physics teacher. Today we are going to talk about Newton first, second and third law, and what are the differences between Newton first law, Newton second law, and Newton third law. Before talking about Newton first law, second and third law, I imagine that I asked Newton a question. What happens if a force acts upon an object, or what happens when there is no force acts upon an object? First, we should know what is meant by the force, or what is the effect of the force. If a force acts upon an object, the object state should change, which means the object should acquire an acceleration. Again, if a force acts upon an object, the object state should change, or in another way, the object should acquire an acceleration. Acceleration means that the object speed should change, and the object speed means its magnitude or its direction, or both of them. Again, if a force acts upon an object, the object state should change. The object state means its acceleration. The object should acquire an acceleration, which means its speed should change in magnitude or in direction. If it is at rest, its speed should increase, or its speed increases or decreases, or it stops moving. All of these occur when the force acts upon an object. Okay, when we ask the Newton a question, "Oh Newton, what happens if there is no force acts upon an object, or if the resultant force that acts upon an object equals 0. Newton said that the object state doesn't change. If it is at rest, it keeps its state at rest. And if it is moving with a uniform velocity or constant velocity, its velocity doesn't change, doesn't increase or doesn't decrease. So if there is no force acts upon an object, the object state doesn't change. This is what's meant by Newton's first law. So Newton's first law says that the static object keeps its state of rest, and the moving object that moves with uniform velocity or constant velocity keeps its movement with uniform speed unless an external influence called force acts upon this object. So if there is no force acts upon an object, or there are some forces that act upon an object, but these forces cancel each other, so the resultant of these forces equals 0, which means there is no force acts upon this object. The object state doesn't change. We said that the object state means its acceleration, its velocity in magnitude and in direction doesn't change. So the object keeps its state of rest, and the moving object keeps a state of motion with uniform velocity unless an external force acts upon it. So Newton's first law answered the question, what happens if there is no force acts upon an object? He answered saying that the object state doesn't change. This is called Newton's first law. In this case, Newton said that if there is no force acts upon an object, for example, if we have a chair that is kept at rest, no force acts upon it, so its state doesn't change because there is no force acts upon it. Or if there is a chair, a person pushed this chair in the west direction, and another person pushed the same chair in the east direction with the same force. So the force of the first person cancels the force of the second person. So the summation of their forces equals 0. So in this case, the chair affected by 0 force. So its state doesn't change because the summation of the forces that act upon it, or the resultant force that act upon it, equals 0. So the state of the chair doesn't change. But what happens when I push the accelerator of my car? When I push the accelerator of my car, there is a force, the car engine force. There is a force that acts upon the car. But when the pointer of the speedometer fixed at a certain number, for example 100 km/h, this means that According to Newton's first law, there must be no force acts upon this car, but there is a force, the car engine force. I still push the car accelerator, but the car speed doesn't change, although there is a force that acts upon this car, the car engine pushing force. Newton said that if the state of the object doesn't change, its acceleration doesn't change, its velocity doesn't change, this means that the summation force or the resultant force that acts upon this object equals zero. So he said that the car speed doesn't change because there is another force that acts in the opposite direction, which is called friction and air resistance. So at the moment when you push the accelerator of your car, there is a force that pushes the car forward, which is called car engine pushing force. But the speed of the car or its acceleration or its state doesn't change, which means that there must be another force that acts in the opposite direction, which is called friction and air resistance. At this moment, the friction and air resistance forces are equal to the car pushing force. So they cancel each other. So the resultant force in this case equals zero. So the speed of the car doesn't change because the resultant force that acts upon this car equals zero. Again, Newton's first law answers the question, what happens if there is no force acts upon an object? Newton said that the object state doesn't change, its acceleration doesn't change, its velocity doesn't change, or its direction. So the Newton's first law says that the static object keeps its state of rest, and the moving object keeps its state moving with uniform velocity or constant velocity unless an external influence called force acts upon it. Okay, this is Newton's first law. But in Newton's second law, Newton answered the question which said that what happens if there is a force acts upon an object? Okay, Newton's first law answered the question what happens if there is no force acts upon an object. He said that the state of the object doesn't change. But in Newton's second law, he answered the question that says that what happens if there is a force acts upon an object. He said that the object state should change. Its speed or its acceleration or its direction should change. So in Newton's second law, if a force acts upon an object or resultant force that acts upon an object, the object state should change. The object should acquire an acceleration, which means its velocity or its direction should change. Again, if a force acts upon an object, the object should acquire an acceleration. Newton said that if a force F acts upon an object, this object should acquire an acceleration. Okay? And this acceleration is directly proportional to the force at constant mass, which means by increasing the force, the acceleration increases and is inversely proportional to the mass of the object at constant forces, which means by increasing the mass of the object, the acceleration acquired by the object decreases. So Newton's second law says that F equals ma. Okay, this a form of or a definition of Newton's second law. There is another definition of Newton's second law which says that the resultant force that acts upon an object is directly proportional to the time rate of a change of its momentum. Okay, what is meant by momentum? Momentum means the amount of movement of the object. Momentum or the object has a momentum only when during its motion. So the static object, the momentum of static object equals zero. Again, the object has a momentum only during its movement. If the object is at rest, so the momentum equals zero. Why? Because momentum of the object equals mass times its velocity. Momentum equals mass times its velocity. So if the velocity equals zero, which means the object is at rest, its momentum equals zero. So the object has a momentum during its motion only. Because so that it's called momentum, which means the amount of movement or amount of motion. Okay, momentum means number one, the effect of collision when the object collides with another object, the vector of collision depends on the momentum of this object. And the momentum depends on the mass of the object and its velocity. For example, if we have two cars, a small car and a large truck, both of them move with the same velocity. So we have constant velocity of both of them, and they collide with a wall. So the destruction of the truck is more. The collision of the truck with a wall is more destructive than the collision of the car. Why? Because the mass of the truck is much greater than the mass of the car, and the momentum of the truck is much greater than the momentum of the car. So the collision of the truck with a wall is more destructive. So the effect of collision depends on what? On the momentum. By increasing the momentum, the effect of collision increases. Again, if we have two similar cars, two small cars or two large trucks, and one of them moves with a velocity, for example, 60 km per hour, and the other car moves with 120 km per hour. Both of them have the same mass, but one of them moves with a velocity larger than the other. So when they collide with a wall, the second car, which moves with higher velocity, 120 km per hour, when it collides with the wall, the amount of destruction is much greater than in the second car or in the first car, because the momentum increases by increasing the speed or the velocity of the moving object. By increasing the velocity, its momentum increases, so the effect of collision increases. So we can say that momentum means the effect of collision. We can also say that when by increasing the momentum of the moving object, the stopping force required to stop this object increases. So momentum means the stopping force required to stop this object increases. Okay, Newton's second law, there is another form or another definition of Newton's second law, which says that the resultant force that acts upon an object is directly proportional to the time rate of a change of its momentum. We can say that if directly proportional to the change in momentum. Momentum should change. The momentum of the object should change. So the mass of the object is constant. So which means that the speed or the velocity of the moving object should change. Okay? So F is directly proportional to the time rate of a change of momentum. Delta PL over delta T. And PL equals mv. So delta mv over delta T. So force equals delta, the mass of the object is constant. So force equals m delta v over delta t. We can say that mv, f final velocity minus initial velocity over time, which equals acceleration. So there are a lot of forms of Newton's second law. F equals delta p over delta t equals m delta v over delta t equals m multiplied final velocity minus initial velocity over time, which equals ma, which is called Newton's second law. So the mathematical form of Newton's second law is F equals delta B over delta T, or F equals m delta V over delta T, or equals F equals ma. Okay, the measured unit of force is Newton, which equivalent to, okay, force equals what? Mass times acceleration. So the measured unit of mass is kilogram, and the measured unit of acceleration meter per second square. So the measured unit of force is Newton, which equivalent to kilogram meter per second square. And the dimension formula of force is, okay, mass kilogram meter per second square, which equals mLT bar negative 2. This is the dimension formula of Newton's second law. Okay, there are some applications of Newton's second law and momentum. The first application, the collision of a truck with a wall is more destructive than the collision of a truck with haystack. Why? In both cases, momentum are equal. The momentum of the moving car or the moving truck are equal, right? So momentum equals what? mv. We say that F equals mv or m delta v over delta t. So mv equals what? M delta v equals ft. Okay, the momentum, which means mass times change in velocity, equals ft. So the momentum mv converted into ft. Okay, if the momentum equals 500, for example, 500 kilogram meter per second, this value will change completely into ft. So ft equals 500, for example. Okay, by increasing the time of what? The time of exchange of momentum from the moment of collision till it stops. When the truck collides with the wall, it stops suddenly, right? So the time of exchange of momentum from from vi till vf, very short time. So t is very small. So the active force on the truck is very large. So the collision of the truck with a wall is more destructive because the time of change the time of change in momentum very small or very short. So the acting force increases because the relation between force and time is inversely relationship. By increasing the time, the force decreases, and by decreasing the time, the force increases. While in the case of collision of the truck with a haystack, the time of change when the truck collides with it took longer time to stop. So the time taken to stop or the time of change in momentum is very large. So the acting force, which is inversely proportional to this time, becomes very small. So the collision of the truck with haystack is very small. Another example about momentum and collision. If a person falls from a building on the ground and the same person falls from the same building but in water. In the first case, when the person falls on the ground, he will be harmed, while when he falls in the water, he will not be harmed. Why? The same reason. Because when the person falls on the ground, the time of change of momentum, which the time between the moment of collision till it stops, is very short. So by decreasing the time, the acting force that acts on the person increases, so he will be harmed. While in case of water surface, when he falls on the water, the time of change from the moment of collision when it falls on the water till it stops, it takes longer time till he stops. So the acting force in this case is very small, so he will be not harmed. Another example, when an egg falls on the ground, it will be breaks down. It will be break down. Well, when it falls on a pillow, it will not be broke. Why? Because in the first case, the time of change of momentum is very small. The time between the moment of collision till it stops is very small. So the acting force is very large. So it causes breaking of the egg. While in case of falling of the egg on a pillow, when it falls on the pillow, it takes longer time to stop from the moment of collision till it stops. So it took longer time till it stops. So the acting force in this case is very small because the time, by increasing the time of a change, the acting force decreases, so it doesn't break. Another example about momentum and Newton's second law, the airbag in cars. What is the idea of airbag? When the car collides suddenly with a wall or with a tree, whatever, at the moment of releasing airbag, it's idea that to increase the time of change between the moment of collision till your face stops, to decrease the acting force on your body. Okay, when the car stops suddenly and your face collides with the airbag, the time between the moment of collision till it stops increases. It is the function of airbag to increase the time of rate of change. okay, to decrease the acting force on your face, to decrease the acting force on your face, because momentum changes into force times time. So the relation between force and time, the force that acts upon your face and the time of change of momentum, is inversely relationship. So by increasing the time, the force that acts upon you will decreases. Okay, this is Newton's second law. What's meant by Newton's third law, and what is the story of Newton's third law? Okay, Newton in first and second law say that if there is no force acts upon an object, the object state doesn't change. First law. In second law, but if a force or a resultant force that acts upon an object, the object state should change. The object should acquire an acceleration. The object velocity should change. The object direction should change according to Newton's second law. But we asked Newton, what happens when we sit on a chair on the ground? There is a gravitational force that acts upon us, right? There is a force acts upon us which is called gravitational force. But we didn't move. Although there is a force which is called gravitational force, the force of gravity that acts upon us, but we didn't move. How can you explain this? So Newton says in his third law the answer of this question. He said that if a force acts upon an object and the state of the object doesn't change, this means that there must be another force that acts upon the same object in the opposite direction and has the same magnitude, which is called Newton's third law, which says that for every action there is a reaction that equal in magnitude and opposite in direction. When you sit on the chair at your home, there is a force that acts upon you towards the center of gravitation, which is called gravitational force, or we can call it the weight. But your body doesn't move. So Newton said that if your body doesn't move, there must be another force that acts upward, and this force equals in magnitude and opposite in direction of the same kind of the first force, which is called the force of reaction. Okay, so there is an action which is the gravitational force that acts upon your body, but your body doesn't move. So there must be another force that equals in magnitude and opposite in direction acts upon you, which is called the force of reaction. These two forces are equal in magnitude and opposite in direction, so they cancel each other. So the resultant force that acts upon your body in this case equals 0, which is called Newton's third law.